In this video, we're going to see how to program on the TI-nspire. To start off with a new document, go Menu, Add Program Editor, and then choose New. This program is going to add up 2 dice, so we'll call it dice sum, and click OK, or press Enter. To get a random number between 1 and 6, you type randint 1, 6, and we're going to store that into a variable called D1. Now we're going to do the same thing, randint 1, 6, and store that into D2. Finally, what we want to do is we want to display, so that's in the I/O menu, input output, and we choose disp, and then D1 plus D2, and that will add up the 2 dice and display it. Finally, we go to menu 2, and we choose run, and that will save our program and then allow us to run it. Press enter, 2 dice adding up to 7, then press enter again, 2 dice add to 5, press enter again, they add to 9, and so on. So basically each time it's rolling 2 dice and adding them up. And you could just use this program if you wanted to add 2 dice and press enter lots of times. But that's kind of boring because we can actually get our program to loop for us. So what we're going to do is we're going to insert a for loop. A for loop's useful if you want to repeat some code multiple times and you know how many times you want to repeat it. So I'm going to change my program so that it repeats it 100 times. So under the control menu, for N4 is what we want. And we're going to say what variable to use. I'm going to use S for simulation. S is going to go from 1 to 100, and we'll just go up by 1 each time. Now, you can see here the code is actually after the N4, and in fact, what we want is that code to be in between the 4 and the N4 line. So what I'm going to do is I'm going to use the Shift button and then select all those lines and cut them using Control X. And then I'm going to use Control V to paste them in between the 4 and the N4. And you don't have to do this next bit, but I'm going to just indent my code a little bit because I like the lines between the 4 and the N4 to be indented. If I'd actually just started off with a for loop, then it would have automatically indented for me. Now I'm going to just choose check syntax and store and then run. And you can see here, it's gone and done it. It's rolled the 2 dice 100 times and just displayed all the numbers. So that's pretty good because then you can look up and see the 100 numbers. But what would be really good is if we could get the calculator to keep track of the different sums. We can use this strategy to figure out how many times the 2 dice again add up to 8, and that will give us an experimental probability of 2 dice adding up to 8. So I go back to my program. I'm going to have to use a new variable to keep track. So I'm going to use C for counter. And now instead of displaying the sum, what I want to do is include a test to see if the 2 dice add up to 8. So under the menu control, so if then end if is what I want. So I'm going to see if D1 plus D2 equals 8. And if that is the case, I'm going to add 1 to C and then store that into C again. That's how you can add 1 to a variable. And then finally, after it's done the 100 simulations, I'm going to display that count. So now let's run this program. Control R, by the way, can also be used as a shortcut for run. And I run the program and I see 14 times out of 100, the dice added up to 8. I can run it again 17 times, then 18 times, 14 times, 13 times, and so on. Obviously, because of the randomness, it's going to give a different result each time. So if you're typing this program, don't expect to get the same answers as this video shows. All right, 100 simulations is good, but actually we could do more simulations now. I'm going to change it to 10,000 simulations just so you can get a sense of how this would all work. So I change S1 to 10,000 this time, and again Control R to run, and it gives me 1,330 times out of 10,000 times. Run it again, 1,386, then 1,412, 1,371, and each time it's running 10,000 simulations and telling you the answer. Just so that we can have some sort of reality check on this, we might like to think about the theoretical probability that 2 dice add up to 8. You could draw a little table with 1 to 6 along the rows and 1 to 6 along the columns. There are 36 possible outcomes, and 5 of them result in 8. And so the theoretical probability is 5/36, and if we multiply that by 10,000, that will give us the expected number. So the expected number is 1388.8 recurring. Obviously, that's never going to be the actual number of times if you do the simulation 10,000 times. But you can see that that's pretty close to all the numbers we got.